For the first lesson, we'll be looking into set builder and interval notation. And these are a couple of ways of representing portions of what we have in the real number system. And okay, first of all, just taking a sample of a graph. And I will apply a few numbers here. And let's say if I apply a graph, and let's say if I have a close point on 1, and let's say if I have an array that is going to go out to the right continuously. Now for that which represents the set builder notation, okay, now we have, again, for the activity we have on 1 and with the array that's going out to the right. Now for the set builder form, what I have here, okay, how this would be denoted. Okay, we have braces as our grouping symbols, and we'll have x to be the variable that represents all the numbers. Okay, so we have array that's going to the right. And since we have a close point on 1, at that spot we have x equal to 1. Everything else is going to be greater than 1. And for the whole set, we're looking at all values of x such that x is greater than or equal to 1. And just for the notation here, for the opening statement, okay, this x at the front is going to refer to the set of all values of x, and we have with the vertical slash, this would be read such that, and then we have for the descriptive terms regarding our inequality statement, we have x is greater than or equal to 1. Now, as for what we have for the interval notation, instead of having braces, we're going to be using instead brackets and parentheses. Okay, and for the interval notation now, we are on 1, and we have going past 1, we have going out to the right continuously, where the values are going to keep increasing. And since we have continuity, this is going to be going out to infinity. And since we have a close point on 1, we have a bracket that is going to surround. And let me mention something about infinities. The reason I have infinity in the parenthesis at the right, we have, for these concepts, negative and positive infinity are boundless. And for the interval notation, they will always be in parentheses. Another case of a number line. And we will let this run continuously at both ends. Okay, so we have continuity happening at both ends, and what this means is that we have the positive numbers, 0, the negative numbers, all the fractions, everything else in between. Now for the set builder notation, we're not just looking at whole numbers or integers or fractions or decimals. We're looking at everything that is involved. And in fact, we were looking at the entire real number system. And for the set builder notation, we would have the set of all values of x such that x is an element of all real numbers. Again, you had the set of all values of x such that x is an element of all real numbers. And for the interval notation for all real numbers, we have going continuously between negative and positive infinity. And so we'll have those values, or those limits, okay, contained in parentheses. Now, another sample graph. Sort of like the first example, okay, something that's not going to consist of all real numbers, but we'll say that we have activity that will be going such that we have an open circle on 2, and we will have a ray that is going to end up going out to the left continuously. Now, when we had a close point on 1, the close point indicated that 1 is part of the graph. In the case of the open circle on 2, because that circle is not closed, that means that 2 is going to be left out of the system. So we have everything else that belongs in the graph is going to be less than 2. And for the set builder notation, we're going to have the set of all values of x such that x is less than 2. For the interval notation, now again we have a decrease going continuously down, approaching negative infinity. And for the upper limit, we're essentially looking at 1.99999 tangent 2, but never quite getting exactly to the value of 2. And for all values of x such that x is less than 2, we have a parenthesis around the lower limit, negative infinity, since we have infinities to be boundless. And since 2 is not included, we're going to have this time the parenthesis to enclose. Now, for the first and third examples, okay, we've had directional inequalities, okay, where we have to fit or to be fitted by one description. Now let's say that if we have what will be referred to as a combined or compound inequality, and putting up a quick case here. And we'll say we have an open circle on 1 and a close point at 3, and connecting the locations. We'll just use a line segment. And for what we have in this particular case, right, so you have values of x that will be greater than -1, and at the same token you have values of x less than or equal to -3. So you have, in one sense, you have x is greater than -1, x is less than or equal to +3, and in terms of piecing together what we have here for these simultaneous occurrences to be described in one statement. You have -1 is less than x, logically the equivalent of x is greater than -1, and x in turn is less than or equal to 3. And for the set builder form, you have the set of all values of x such that -1 is less than x is less than or equal to 3. And for the interval notation, okay, we have the activity occurring between -1 and 3. And you do not have infinity or negative infinity involved. And since we have -1 not included, this being closed by the parenthesis, and we have with the close point at 3, okay, 3 is included, and the inclusion of 3 is going to be indicated by the bracket. And one more case that we have regarding what we have for set builder and interval notation. You'll probably not see a case exactly like this until we get to a calculus-based course. Okay, so you have itemized points at -3 and -1. And we have an open circle at 2 with the ray going out to the right. Now for the descriptions, first point we have only x is equal to -3. Nothing to the left, nothing to the right. And we have, with a close point at -1, we have x is equal to -1. And then we have, with the last portion, we have that x is greater than 2. Now for the set builder notation, what you're going to have here, okay, we still have the set of all values of x such that, okay, so we have with the first item, we have x is equal to -3. Then we have or, we have an x value, we have that x is equal to -1. And we don't have x equal to -3 or x equal to -1. We're going to have instead any value of x that would be greater than 2. Again, that is the set builder notation. And for what we have in interval terms, now again we have itemized values at -3 and -1. And since we're exactly on -3 at the start, okay, that is going to be enclosed in the brackets. And we have -1, that is its own point, it is included, that is also in brackets. And with x is greater than 2, now we have going past 2 on out to infinity, and 2 is not included, infinity is boundless. So we're going to have for this last particular section, we're going to have parentheses. And let me mention, you know, for this U symbol, this is going to refer to the union of elements, sets, or intervals.